So today I wanted to talk about exploring immunological assays to assess responses to pneumococcal, plain polysaccharide, and conjugate vaccines. And this work was all produced as a result of going to the Den Bosch meeting, which was in May, which Luminex sponsored, because I've worked on a clinical trial called AIR, investigating responses to these two different vaccines in HIV for the last 4 years. So one of the questions was, well, have you looked at subclasses? And I was like, no, but definitely that's something that I wanted to do. So this is a result of my last 6 months of work in the lab. Okay, so first off, background and names. I wanted to look at assessing the responses to pneumococcal vaccination and how it's important with regards to determining immunogenicity and immune competence. So the aims of the project were to qualify the IgG subclass response to the plain polysaccharide vaccine Pneumovax, which contains 23 different polysaccharides, and the protein-conjugated Prevnar 13 vaccine, which is conjugated to a diphtheria protein called CRIM197. And then I wanted to compare the individual pneumococcal serotype responses to combined serotype assays for both vaccines. So to achieve the aims, well, first I had to develop the assays. So I developed pneumococcal specific G1 to G4 subclass assays for the Luminex platform. And I used the 100 and 200 for all of my research. So then we conjugated Pneumovax and Prevnar 13 beads to, or vaccines to beads for a multiplex Luminex assay. And then I also had to assign the G1 and G2 values for the 007 standard, as these values were only previously assigned for the 89SF standard. And then we wanted to compare the Luminex assays with commercial whole pneumococcal IgG and IgG2 ELISAs available from binding site. So, methods. So for the G1, G4 assays, so I had to get monoclonal antibodies and conjugate them as my secondary antibodies. So they offer a higher degree of specificity than polyclonal, which are used in most of the commercial kits. And these were kindly donated from Dr. Margaret Goodall, who works in the clinical immunology service at the University of Birmingham. And any of the monoclonal antibodies that I show today, any of that research, you can, they're readily available from her and Abingdon Health from Seroscience. So then I had to conjugate them to phycoerythrin using lightning link kits by Innova Biosciences, and it's quite a simplistic conjugation kit to use. It basically takes about 3 hours to conjugate and use an LL modifier, and you can quench within 30 minutes, and the conjugates are ready to use. You can check them as well after the conjugation step. So then I had to optimize the concentrations with titration studies to make sure that I achieved consistently high immune fluorescent intensities. And so I had to measure the 5 multiplex Luminex assays to total G, G1, G2, G3, and G4. And I'm only going to talk about 11 pneumococcal serotypes today instead of our 12 that we normally use. So based off of 2 papers that were, I believe that came out in 2000 and 2001, the serotypes that were used were 1, 3, 4, 5, 6B, 7F, 9V, 14, 18C, 19F, and 23F. They didn't actually assign values to 19A, so I'm only talking about 19F today in this presentation. Okay, so with the vaccine beads, so we had to conjugate Pneumovax to the beads using a polyL lysine linker. And the method that we used for that paper is available by my group, which was published in 2012. Then we had to conjugate Prevnar 13 directly to the bead. So CRIM197 is the protein backbone of this vaccine. And we were able to directly conjugate with the bead in the presence of NHS and EDC. And once again, the MFIs were optimized for all of the titration experiments. Then I had to analyze the whole PCP IgG and the PCP IgG2 kits, which are available via binding site. And it's important to note that all of these kits basically use 23 different serotypes as that are included in Pneumovax as the coding antigen. So then we compared the results with the assigned values for IgG and the IgG2 Luminex assays that I've developed. And the samples. So the samples were tested on 50 HIV patients, or serum samples from 50 HIV patients, which were available from the clinical trial that I worked on called AIR. and the blood was taken pre and post-vaccination. So 25 patients had a single dose of Pneumovax, and 25 patients had a single dose of Prevnar 13. Okay, so then I had to assign G1 and G2 values to 007 from 89SF. So I used an equivalence of absorption method from 89SF to the 007 standard. And please note that not all of the MFIs would reach over 1,000 as we use monoclonal antibodies, so these are much more specific than polyclonal antibodies. And they bind a single epitope as opposed to multiple epitopes, which polyclonal antibodies do. We then ran standard curves in triplicate for IgG1 and IgG2 to establish the dynamic range of the assay, and I used 16 points and doubling dilutions for all the serotypes tested. We then used a Masterplex reader fit curve fitting analysis software to utilize 4 or 5 parameter logistics, curve fitting algorithms that were suitable for all of the 11 serotypes to determine values for 007SP. And the specificities of these human IgG subclasses have been established in collaboration with the World Health Organization and the International Union of Immunological Societies, and the papers are going to be referenced at the end of the slide. So I obtained murine monoclonal anti-human IgG 1, 2, 3, and 4, as I said, from Dr. Margaret Goodall as well, which are available if you do want to use them in your own assays. Okay, so then we wanted to look at the IgG subclass response to vaccination. So the initial analysis was to examine MFIs pre and post-vaccination for IgG and IgG 1 to 4. So for the PPV-23 vaccine serotype cohort, the IgG2 response was greater than IgG1, which you would expect, because with a polysaccharide vaccine, it should generate predominantly an IgG2 response. However, there was still quite a strong IgG1 response, and there was an IgG3 and IgG4 response. For the PCV13 vaccine cohort, the IgG1 and the IgG2 responses were equivalent. Now that was quite surprising because we didn't think that we would actually get much signal for the IgG2 assay, but actually we had an equivalent response, which was quite interesting. And it's important to note that this was greater than IgG3 and IgG4. The IgG3 response was much higher in the Prevnar 13 cohort than the Pneumovax 23 cohort. And the IgG4 response, although it was still there, it was quite limited for both of the PPV and the PCV vaccine cohorts. So then we wanted to look at fold changes. So it's important to note that the G1 to G4 responses are different for pneumococcal serotypes. And the absolute values differ vastly. The fold change does differ between different serotypes. And this is also different between Pneumovax and Prevnar 13 cohorts. So what you can see is that I've ranked the fold change for all of the vaccine cohorts and for all of the serotypes. And what's quite astonishing is that serotype 1 actually has the highest fold change rank across all of the G to G1 to G2, G3, G4 assays. This may be because it's an invasive serotype and it's not prevalent within the community, so therefore when a vaccine cohort receives this vaccine, they mount a greater response. Oops. Okay, so those are the other ranks as well. For all of the other subclass assays. So you've got G1, G2, G3, G4. It's important to note as well, so I'm not sure if you're familiar with these pneumococcal Luminex assays, but when we actually investigate serotype-specific serum levels, antibody levels in our patient cohorts, many of our patients have extortionately high titers to serotype 14. And if you look at the subclass assays, there's a lower fold change for most of the subclass assays. And I believe this is because it's a common serotype that's prevalent in the community. Therefore, the fold change isn't as great in both of these vaccine cohorts. So then we wanted to assess the quality of the IgG response in an individual. So this suggests that the proportional amount of IgG1 and IgG2 produced is different for each serotype. So we went on and examined ratios. So these graphs, I apologize, you might not be able to see all of the axes, but they basically show the percent increase or decrease of IgG to IgG1 and IgG to IgG2 ratios for each pneumococcal serotype from pre to post vaccination for the Pneumovax and Prevnar 13 cohorts. And what you can see is that they're vastly different. So then we wanted to look at whole IgG versus IgG subclasses for the Luminex assays. And there's a significant increase in whole IgG titer for each serotype, and this differs when you're considering examining the various subclasses. So the subclass analysis offers a further understanding of the IgG response to different vaccines, and it also shows the granularity of the response because it's very different for each serotype. So this is just a summary slide. I couldn't show every serotype because we would be here the whole day. So, so I've just showed one serotype here, and this is serotype 1. So my first panel is showing the absolute values for serotype 1 for IgG, IgG1, IgG2, IgG3, and IgG4. Now, significant differences were detected pre to post vaccination for each of the vaccine cohorts. What the distinguishing feature is that for the IgG group, for the Prevnar 13, there was more IgG produced for the Prevnar 13 group for IgG and IgG2 assays as opposed to IgG1, 3, and 4. And then we wanted to look at fold change. Now, I didn't detect any significant differences between these two vaccine cohorts, but what you can see from the graph is that they are remarkably different. It appears that Prevnar 13, if you look at the fold change for the pneumococcal-specific IgG assay, is much greater than the Pneumovax vaccine cohort. The G1 response for the fold change is equivalent. The G2 is much greater in the Prevnar 13 cohort, and there are vast differences between IgG3 and 4. And then we looked at ratios here. So I detected a significant difference with regards to the proportional amount of IgG to IgG1 produced in the Prevnar 13 cohort. So what that means is that there's a greater amount of IgG produced as opposed to IgG1 in the Prevnar 13 cohort. So, and I've done this for all of the different serotypes. So I'm not going to go over that today. Okay. So then we wanted to look at pneumococcal serotypes versus novel, less complex, whole pneumococcal assays. So the pneumococcal serotype assay offers information about the breadth of the response, about the granularity, about the differences from serotype to serotype. The downside in a clinical routine service is that it's costly, the time costs, as well as the complexity of reporting multi-parameter results. And whole PCP IgG assays are available for the ELISA. However, they're not available for the multiplex immunoassays that we use on the Luminex platform. So how would a whole Pneumovax and Prevnar 13 bead-based system assay compare with the existing pneumococcal serotype assays? So we wanted to compare the whole vaccine bead assays to 8 out of 12 pneumococcal serotypes, which is the gold standard for, based off of the World Health Organization threshold, which is 0.35. So when we compared whole Pneumovax and Prevnar 13 beads with the serotype data, the ROC curve analysis for the prediction of patients who reach threshold for the serotype-specific IgG returned an area under the curve of 0.68 against the whole Pneumovax bead and 0.87 against the whole Prevnar 13 bead. Now, if you think about this, it might be because we test the 12 serotypes that are included in Prevnar 13 are the serotypes that we test on our panel, whereas we're not including the other ones that are included in Pneumovax. I believe that's why the Prevnar 13 bead is better at predicting 8 out of 12 serotypes that we have protection for. And then I wanted to break it down further. So, is it different between vaccine cohorts? So then we looked at Pneumovax and Prevnar 13 vaccine bead IgG responses post-Pneumovax and post-Prevnar 13 vaccines. And so the first ROC curve on the left-hand side is showing the Pneumovax and Prevnar vaccine bead post a single dose of Pneumovax 23. And what you can see there is that the Prevnar bead is better at predicting 8 out of 12 pneumococcal serotypes protected post-Pneumovax vaccination. I believe it returned an area under the curve of 8.825. The next graph is showing, the next raw curve is showing Pneumovax and Prevnar 13 vaccine bead responses post-Prevnar 13. And once again, the Prevnar 13 bead was better at predicting 8 out of 12 serotypes. And the area under the curve was 0.87 compared to 0.731 for the Pneumovax bead. So then we wanted to look at how do the whole vaccine bead assays compare with the binding site PCP IgG assay. So for IgG serotype assays, as I've said before, protection is deemed significant when 2/3 of the measured serotypes reach the 0.35 microgram per mil threshold. Now I know this is different in the States as they use a 1.3 microgram per mil threshold. The binding site assay is an ELISA using a polyclonal secondary IgG antibody using 23 different serotypes found in Pneumovax. And when our serotype data was compared with the whole PCP IgG assay, 36.4% of patients that were deemed protected by the whole PCP IgG assay had a significant number of serotypes that failed to reach threshold. So what that's saying is that the whole PCP IgG assay is actually misdiagnosing patients if you're comparing it to the pneumococcal specific IgG assays. So how does our pneumococcal IgG2 Luminex assay compare with the binding site PCP IgG2 assay? So these are just some results from the IgG2 binding site assay. And there were no post-vaccine differences between the Pneumovax and Prevnar 13 cohorts, which is actually similar to my Luminex IgG2 data. However, if you consider the fold change post-vaccine, although there were no differences between the total anti-PCP IgG2 produced, patients that received a first dose of Pneumovax initially produced a greater amount of IgG2 than patients that received a first dose of Prevnar 13. So how does our pneumococcal IgG Luminex assay compare with the binding site? So what you can see is that I've included the 11 serotypes that I've tested, and the IgG2 response varied widely with our Luminex assay. There's a 1.34 to 9.38 median fold change between the serotypes and vaccine cohorts. And these are differences that are potentially masked by the whole PCP IgG2 assay. So on the left-hand side of each graph, I've included the fold changes for the anti-PCP IgG2 assay for Pneumovax and vaccine cohorts, so that stays consistent throughout the graphs. And then I've also included the serotype-specific IgG2 Luminex data. And what you can see again is that serotype 1 actually returns the best response. There's a 10-fold difference for both PPV and Prevnar 13 vaccine cohorts and the MIA, which is definitely masked in the PCP IgG2 assay, which only returns about a 4-fold change for the Pneumovax cohort and less than a 2-fold change for the Prevnar 13 cohort. So with serotype 4, there's a disproportionate fold change if you're considering the binding site assay to the Luminex as well. With serotype 14, it seems that there's a better response if you're considering the binding site assay, but not for the Luminex. And for 19F, it's a better response if you're considering binding site, but once again, not for the Luminex, which returns less than a 2-fold change for both vaccine cohorts. So what I'm just trying to say is that, if you're using the whole PCP IgG2 ELISA, then potentially you're masking really pertinent information for each serotype. So I think with regards to this conclusion, the study has demonstrated differences in IgG subclass responses to Pneumovax and Prevnar 13 vaccines. This challenges previous thinking that a plain polysaccharide response is predominantly G2 and the conjugate vaccine is G1, as you can see from my data. And the study also highlighted the variety of assays available and that these generate very different results. And the serotype-specific assays demonstrate that responses to individual serotypes are very different for both vaccines, and that the granularity cannot be visualized in combined serotype assays. So serotype-specific assays are the way to go. So tips and tricks for Luminex assays. So need to list a few things here. For the 100 and 200, daily calibration, which you may know, monthly validation of the machines and needles. So if you have lots of sticky serum samples and you use a 50-plex or a 92-plex, you want to make sure that you're sonicating your needle every day and you're flushing through with DI water. You want to make sure that you're establishing the lower limit for your standard 1 MFIs. Make sure that you have clinical limits of reporting values for the assay. Make sure that you know your reference ranges for your observed expected values. Make sure that you've set your CVs and check your standard curves for each serotype that you're testing. So I just want to say thank you for inviting me to speak here today, and just a shout out to my supervisor, Dr. Alex Richter, and also Margaret Goodall, for which if I didn't have her help, this work couldn't be completed. So thank you very much.